A 0.8 meter cube container at 60 degrees Celsius is filled with 0.6 mole ideal gas. The gas is isothermally compressed to a volume of 0.2 meter cube. Okay, so this is the first process. Okay, and the process will continue. Then the gas expands isobarically to its initial volume. So this is the second process. And the question asks us to look for the total work done in the processes. So for this question, I'll draw the graph. It will be better because you can understand better. Okay, let's draw the graph. The graph of PV against. Okay, let's draw graph for PV graph. Pressure against volume graph. Okay. So this is your pressure, and this is your volume. So your volume will be in meter cube and your pressure will be in Pascal. So first of all, the gas is isothermally compressed to a volume of 0.2 meter cube, and we know this is the initial volume. So this is the final volume 0.2 and the initial volume is 0.8. And we have two pressure, so pressure 1 and pressure 2. Okay, let's draw the curve for isothermally compressed. So it is compressed from 0.8 to 0.2 millicube. Okay, give me one moment. So it is compressed, so therefore you will get your curve like this. Okay, this is a curve. Okay, so this arrow pointed upwards means the volume is compressed. Okay, then we are done drawing for the first process, and for the second process the gas expands isobarically. So when it's expand isobarically means constant pressure. So the pressure is constant, whereas for isothermal it is constant temperature. Okay, so constant pressure. So when it's constant pressure, you will get the graph like this, because it is constant pressure and it will expand. It will expand to its initial volume, which is 0.8 meter cube. So this is the graph. So this is the first process and this is the second process. The first process is isothermally compressed, whereas the second process is isobarically but expands. Okay, now the question asks us to calculate the total work done in the processes. So we do one by one. Okay, let's calculate the work done for the isothermal process. So we know for isothermal process, the work done formula is nRT ln V2 over V1. So number of mole given is 0.6, molar gas constant is 8.31, the temperature is 60, we need to convert it into Kelvin, plus 273.15 ln, and your volume. Your initial volume is 0.8 while your final volume is 0.2 because it is compressed. So when it's compressed, it's from bigger volume to smaller volume. And when you press your calculator, you will get your work done negative 230.2.75 joule. So we are done looking for the work done for the first process. Okay, now let's look for work done for isobaric process. So we know in order for us to look for work done in isobaric process, we will use formula pressure times change in volume. So the pressure that we are going to look for is pressure 2. Okay, pressure 2. And we can look for it using formula PV equals to nRT. So pressure 2 equals to volume equals to nRT. So the pressure 2 is we are going to look for, alright, and then the volume here We're going to look for pressure too, right? So the volume here is 0.2. The number of mole is given in the question 0.6. Molar gas constant is 8.31, and the temperature is 60, is it? Yeah, 60 plus 273.15. We need to convert it into Kelvin. So you will get your pressure is 8305.43 joule. When you already have your pressure, you can put in this equation. Pressure is 8305.43 and changes in volume. Okay, changes in volume for isobaric, it expands. So it expands from the volume of 0.12 to volume 0.8. So it's going to be changes in volume is final volume minus initial volume. So our final volume is 0.8 and our initial volume is 0.2. So your work done for isobaric process is 4983.26 joule. So we are done looking for work done for isobaric process. But the question asks us to look for total work done. So the total work done will be work done for isothermal process plus work done for isobaric process. So the isothermal is negative 2302.75 joule plus 8305.43 joule. So you press your calculator, you will get 2680.51 joule. So you need to know for isothermal, it is isothermal compressed. So isothermal compression lah. So compressed. So it compressed from 0.8 the volume to 0.2. Whereas for isobaric process, it expand. So dia mengembang. Bila dia mengembang, volume dia meningkat. Jadi dia adalah daripada 0.2 ke 0.8. So this is how you tackle this question. So if you are confused, it will be great if you draw the sketch the graph first. So from the graph, you can understand it better. So this is how you tackle the question for number 6.